Hello students, today we are going to discuss a very important concept, differential calculus. Now I'll create a playlist, topic differential calculus. Now under this playlist I will have around 10 videos, and what will be the topic that I'll tell you one by one. So the very first topic will be the relation between Cartesian and polar coordinates. I'm just listing down the topics. I may mix two topics sometime in one video, like that I'll do, but yeah, whole content will be this. So the first topic will be relation between Cartesian and polar coordinates, radius vector and vertical angle, which will be a new concept for you. Then angle between radius vector and tangent, which is represented by phi, and it will be the hero of the whole module. Okay. Angle between two curves, orthogonal curves, pedal equation, and then this will be part 1 basically. These all first 6 topics are connected. So first I will introduce you Cartesian coordinate. You already know. I will tell you what are the polar coordinates, which you have used earlier, but now we will do the connection between both. Then what is a radius vector, what is a vertical angle, what is the angle between radius vector and tangent, how to find out angle between the two given curves, what are the orthogonal curves, what is the meaning of pedal equation, and how to find out pedal equation for the curve. So these all 6 topics are connected, and the basic concept behind these 6 topics is this phi. So in all the topic, though I have listed them 6 topics, but in every topic the base will be to find out the phi. Okay, then the second part of this playlist will be the concept of curvature and radius of curvature. In this also we will have 4 categories: Cartesian form, parametric form, polar form and pedal form. So Cartesian and parametric you have already done, polar now we will learn, and then pedal also we will learn in the 6th point. Right? Now before you start with this module, or before you start with this differential calculus and you want to cover all these topics, you must know these concepts which you have already studied in your 11th or 12th grade. First few properties of basic properties of log, like log mn is equal to log m plus log n. Log m by n is equal to log m minus log n. M log n is equal to log n to the power m. Now here one very important thing, there is one question which you will come across where the very common mistake students will do, that if you have log m plus n, okay, they write it as log m plus log n, which is wrong. This is not equal, right? So this you have to take care, okay, this is not equal, okay. So in log, these basic properties I have to remember. Then comes the trigonometric portion. Now in trigonometric portion, you need to know the basic concept of two things. First, few half angle formulas. Half angles formula means, what is the formula for sine 2 theta? We all know 2 sine theta cos theta. If it is sine theta, means I'll write 2 sine theta by 2 cos theta by 2. So basically this angle become half here. That's why it is called the half angle formula. So one will be this. Other will be 1 plus cos 2 theta is 2 cos square theta. 1 minus cos 2 theta is equal to 2 sine square theta. Right? Then there is this angle formula which you need to remember, which I will be using when I have to find out the angle between two curves. Okay? And then very important concept where most of the student face problem is the concept of allied angles. Now I will not suggest you to mug it up. Actually, you have learned this in 12th grade. If you remember, you used to say like that, all students take coffee, right? And then we say in first quadrant, all trigonometric functions are positive. In second, sine is positive. Third, tan is positive. And fourth, cos is positive. And then in this, you will be requiring all those concepts. Sine 90 plus theta is how much? Sine 180 plus theta is how much? So now this concept you have already studied in 12th. But if you have any confusion, in description I will put a link where I have prepared a small video to understand these allied angles. Okay, along with that I'll put in the comment box also that link, or I will add that video in this playlist also, so that you can understand that concept. So if you start the module after knowing these concepts, it will become little bit easy for you. Module is very easy. Yeah, it is lengthy and a lot of variety is there. So don't worry about that. Slowly, one by one, we will do the topic and it will be clear to everyone. Okay, so let us start with the very first topic, that is the basic concept of Cartesian and polar coordinate. See, we all know that when I want to represent a point in a coordinate system means what? When you have y-axis and when you have x-axis, correct? And if I want to represent a point P here, suppose P is any point, so usually we write x comma y, right? We write x comma y. Now what is this x and what is this y? So if you remember, this x is a perpendicular distance from y-axis. So this line is basically x. Okay, this line is basically x, that is a perpendicular distance from x. If you see, usually we look at the x-axis. And what is the y coordinate? Y coordinate is what? Perpendicular distance from the x-axis. So this is your y coordinate and this is your x coordinate. This is how we represent all the points. This is a basic thing which you have learned in coordinate system from your 9th grade you are learning. Now what exactly we want to introduce? See, when you have the straight lines, okay, when you have the straight lines, it is always preferred to use the Cartesian coordinates. Like every point of the line I can represent, suppose you have this line, every point of the line you can represent by different points, right? Like x1, y1, x2, y2, like that. But when you have the curves, okay, when you have the curves, that time we prefer to use the polar coordinate as compared to the Cartesian coordinates. Now what exactly is that? Let us understand. Now suppose you have y-axis and you have x-axis. Correct? I already know if there is any point, it is represented like this. Now I am saying I am learning a new system. This is a Cartesian system. Okay. We are learning now new system, polar system. What is this polar system? If P is a point, okay, and it is represented by r comma theta rather than x comma y. Now what is this r? This point here, it is called origin. Everyone knows this, okay. But when I talk about polar, this is called pole, okay. Now this is called the x-axis, this is called the y-axis. But here this line is called initial axis, initial line, okay. Now what happened? When you join this pole to any given point, okay, then this length OP is r and it is known as radius vector. Okay, now this line will make certain angle with the initial line. That angle is represented by theta and which is known as vertical angle. Right? So my simple basic concept is that if you have, suppose this system I will make. Actually y-axis is not required, only initial line you can do, but since we are used to, so I am doing like this. Now suppose if there is any curve like this, okay, and there are different points on this curve, 1 point, 2 point, 3 point, 4 point. So how I will represent the coordinate for this line? It will be this coordinate of this point. Suppose P is r1 theta 1. So this will be r1 and this will be theta 1. Correct. Now suppose if I am talking about this point, so what I will do, I will join this. So suppose it is P2, R2 and theta 2. So this line will become R2 and this angle will become theta 2. If I am talking about this point, I will join this. And suppose it is Q, R3, theta 3. So this line will be R3 and this will be theta 3. So instead of the perpendicular distance from the x-axis and y-axis, now I talk in terms of radius vector and angle. So even if you have a spiral or any curve with so many turns, it is easy to handle with the help of angles rather than the perpendicular distance. Okay. So that is what we have to learn now. Cartesian you already know, and now I have explained you what exactly is a polar coordinate system. Now let us see one more thing. Suppose I have this concept now. Okay, right? Now I have a point P. Now I can say it is r comma theta. At the same time I can say P is x comma y. Right? Now when I say r comma theta, what I will be doing? I will be joining this. I'll say this is r and this is theta. At the same time, if I'm saying p x comma y, this point is p x comma y, Cartesian form. So what I'll do, I'll drop a perpendicular here and this will be your y. Correct? Same way, if I drop a perpendicular here, it will be your x. Now you look at this small triangle. Okay, this is a right angle triangle with an acute angle theta. So what you can say about this triangle? What is the value of sine theta here? Sine theta is perpendicular upon hypotenuse. What is perpendicular here? Y. Okay, this is a perpendicular, this line. So perpendicular upon hypotenuse. Hypotenuse means this line. So y by r. Same way, cos theta is equal to base upon r. So what is the base? Base is this line. What is this? This is x. So x by r. Right? Now from this, what I can write? I can write y is equal to r sine theta. And from second one, I can write x is equal to r cos theta. So this is a relation between polar coordinate and the Cartesian coordinate. X is equal to r cos theta, y is equal to r sin theta. Now, if you square these two equations, this equation and this equation, and add them, what will happen? See, x square plus y square is equal to r square sin square theta plus cos square theta. And sin square theta plus cos square theta is what? 1. So this is very important relation. X square plus y square is equal to r square. And if you divide this, what you will get? Theta is equal to tan inverse y by x. This is another very important relation. How I got this? See, if you divide it, y by x is equal to tan theta. So theta is equal to tan inverse y by x. So you have to remember this, you have to remember this, and you have to remember this. This will be very helpful. These two will be very helpful when you will study the partial differentiation, especially Jacobians and all. That time it will be very much useful. Okay, so now I have explained you what is a radius vector. I have explained you what is vertical angle. I reminded you what is a Cartesian coordinate system, which you were already knowing. I have just refreshed your memory. Then I have taught you what is a polar coordinate, and we have learned what is the relation between Cartesian and polar coordinate. Right? Now, once you are done with this, so now basic idea I got. So now let us see what is the next thing I need to understand. See, in my first, when I listed out all the topics, I told you I will be telling you the relation between Cartesian and polar coordinate. We are done. I told you what is radius vector and vertical angle. We are done. Now, angle between the radius vector and tangent, that is phi, which I said is a hero of the whole module. Right? So now let us learn what exactly is this phi. For this, what I will be doing, I'll just let me draw one thing. I'll take this. Okay. I'll take this. Now suppose there is any curve like this, say f is equal to r theta, means this is a function of the polar curve I have given. Okay, and suppose there is any point P on this, and this is a tangent passing through P. Okay, this is a point P, r comma theta, and this is a tangent passing through this. Now where is the r in this diagram? Very clearly, when I join this pole with P, this is r and this angle is theta. Now, again read the word very carefully. What I said, angle between the radius vector means this, okay, and tangent means this line. So where is the angle? This is the angle. So this angle is a phi, which is a hero of the whole module, and in all the questions I will be finding out this phi. Okay, now before deriving a relation of this phi, which is very important for exam point of view, I'll just extend this line and I'll say that this is, say, psi. Correct? Now let us derive a relation which will give you or which will help you to get the value of this phi. Okay? Now if you observe, I have a triangle. This is O, suppose this is A. OAP is a triangle. Okay. Can you think or tell me what is the relation between the three angles I have made? One is theta, one is phi, and one is psi. What could be the angle? We know that the sum of interior angle is equal to exterior angle. So can I say that this psi is equal to theta plus phi? Any confusion? No confusion. Very simple concept. Now what I am doing? I'll take tan on both the side. So I am doing tan psi is equal to tan of theta plus phi. Now what is this? Tan psi is equal to, what is tan theta plus phi? It is tan theta plus tan phi upon 1 minus tan theta tan phi. If you remember, this is a formula of tan A plus B. Right? So I got this. Let me name it equation number 1 and leave it here. Okay. Now I will try to look into this psi in other way. From the other side, I will check. Now this psi is basically the angle which the tangent to this curve is making. So what exactly it represents? What is the slope of any curve? The slope is obtained by making a tangent and then obtaining the angle which it make with the x-axis. Right? So I can say that the slope of the curve is given by tan of psi. But at the same time, we also know what is the meaning of differentiation. Differentiation is dy by dx. So tan psi is also equal to dy by dx. Yes or no? So very easily I was able to connect ki what is this psi and how I can represent it in terms of y and x. Now I know that y and x belong to Cartesian form, and we also know that y is equal to, okay, I'll write here, y is equal to r sine theta and x is equal to r cos theta. This we already know. Correct? Now I have tan psi is equal to dy by dx. But I am not interested in y and x because I am working in polar coordinate. I want to bring r and theta into picture. So can I do it or rewrite it as dy by d theta upon dx by d theta? We can do it, right? So but if I am doing like this, I should know the value of dy by d theta and dx by d theta. So let's work on that. So tan psi is equal to, what is dy by d theta? So I'll do here to explain you. If you are good in differentiation, you will understand directly. X is equal to r cos theta. Okay. So if I differentiate both the side with respect to theta, what will happen? Dx by d theta is equal to, here you need to apply the product rule. What is the differentiation of r? dr by d theta, because I am differentiating with respect to theta into cos theta. Okay, then differentiation of cos theta is minus sine theta into r. Right? Same way, when I look into this, I want to find out the value of dy by d theta. So now y is equal to r sine theta. Again apply the product rule. So dy by d theta is equal to differentiation of r is dr by d theta into sine theta plus r cos theta. Differentiation of this into this plus differentiation of this into this. That's it. Now these both value I will substitute here. What is dy by d theta? It is sine theta dr by d theta plus r cos theta upon, what is dx by d theta? It is dr by d theta cos theta minus r sin theta. Correct? Actually, what I am planning to do is that I got one expression for this. Again, I am getting another type of expression for this, and I will compare the values. Okay, I'll compare the values. Now, in the first equation, I see that everything is in terms of tan theta. And when tan theta will come? Whenever you have sin theta upon cos theta. So, definitely here, I need to divide it by cos theta. So, what I'll do, divide numerator and denominator by dr by d theta cos theta. There is a reason to select this. I'll tell you the reason. Or probably when I'll do, you will understand. Tan psi is equal to, now first term. This term if I divide by dr by d theta cos theta, what I'll get? Tan theta. Okay, because dr by d theta cancels, sin by cos is 10. Plus. Now cos theta, when I divide this term by this, cos theta will go, and r d theta by dr. Okay, upon, go to the denominator. When I divide this by dr by d theta cos theta, I get 1. And when I divide this term by dr by d theta cos theta, what I'll get? Minus r. Okay, sin by cos is tan theta. And when I divide by dr by d theta, it will become d theta by dr. Correct? Now this is your equation number 2. Now compare equation number 1. Okay, and compare equation number 2. Now the first term here is tan theta. First term here is tan theta. Now the second term here is tan phi. What is the second term here? R d theta by dr. Now if you look at the denominator, here it is 1, here it is 1. To bring this 1, I picked up this term and I divided numerator and denominator by this term. Okay. Then tan theta is there. Tan theta is here also. Okay. Now whatever is left, here r d theta by dr, and here numerator also r d theta by dr, and here what is there in place of that? Tan phi. So when you compare both the relation, what you can observe? A very simple thing. I am getting tan phi is equal to r d theta by dr. So this is one relation I got for my hero phi. Okay, if you take reciprocal of this, what will come? Reciprocal of tan theta is cot phi. So cot phi is equal to 1 by r dr by d theta. So this is our main formula, and how they ask in exam this, they will say derive a relation between radius factor and angle between the tangent. Sorry, derive a relation between the angle between the radius factor and tangent to the curve. So that time you have to derive this. So you will be starting with this. You will draw the diagram and then you will write this, and then you will write tan phi first relation, and this is the whole derivation you have to write down. Okay. So this is the formula I will be using in each and every question. Correct? So now what I will be doing, this you understood one concept. Now here I will explain you one more concept, and in the next video we will start doing the questions. One by one we will pick up. In one video I will teach you how to find out this phi in the questions. In another one I will teach you orthogonality and angle between the curves, and then we will go for the pedal equation. Now when you talk about the pedal equations, what is exactly is the pedal equation? I'll just give you a rough idea. Now again I'll do the same thing. I'll make a graph, suppose this is a curve, and there is a point P r comma theta here. Now if this is P r comma theta, if you join this is your r and this is your theta. Now you are making a tangent here like this. Correct? It is not exactly tangent, just think it is a tangent like this. Okay, tangent should touch only at one point, not 2 points like this. Now what I am doing exactly here, I am dropping a perpendicular here. This is a perpendicular. It's not looking like a perpendicular. Let me draw another diagram so that it will be more clear to you. If we little bit bend the curve, then you will get the correct diagram. Okay, so I'll make it like this. So it will be visible, otherwise you will get confused. So this is P r comma theta. Okay, so if I draw the tangent here like this is theta. Now if I drop, again it is going here. Wait, if I draw there, you won't be able to visualize the diagram properly. That's the reason I am trying to change the orientation of the curve. Right, so I'll do it again. Okay, so let me do like this. And suppose this is a point. Yeah, now we will get. This is a tangent P r comma theta. So now this is your r, this is theta, this is phi, and this is psi. Correct, the same diagram, only the curve I have bended so that I can draw the tangent coming towards the pole. Now what I am doing, I am dropping a perpendicular from pole to this tangent. Now perpendicular means this is 90 degree. Now can you see this right angle triangle? This one. I'll just highlight this. This is a right angle triangle. Correct? Now for this triangle, tell me what is the value of sine phi? Now sine phi is perpendicular upon hypotenuse. What is a perpendicular? Perpendicular is this line. Suppose this is P. This is the length of perpendicular from pole to the tangent. It is always represented by P. So perpendicular upon hypotenuse. Hypotenuse is what? R. So P is equal to R sine phi. This equation is very important equation, and this is called the pedal equation. So basically pedal equation is the relation between P and R. Okay, pedal equation is a relation between P and R. So whenever you have a Cartesian form, somebody is saying Cartesian form, you will see an equation in X and Y. Whenever somebody says polar form, you will have an equation in R and theta. Whenever somebody says pedal form, it is an equation between P and R. Okay, now since P is equal to R sine phi, I'll just write the one more form of pedal equation. If I take the reciprocal and square it, so it will become 1 upon sine square phi. What is 1 upon sine square phi? 1 upon sine square phi is nothing but cosec square phi. Yeah. Now what is cosec square phi? It is 1 plus cot square phi. There is a reason to do this. See, 1 by p square is equal to 1 by r square. 1 plus what is cot phi? Cot phi is our main formula. Cot phi is 1 by r dr by d theta. So 1 by r square dr by d theta square. Right? So this is another form of pedal equation. Correct? So I have taught you two relations, two very important formulas. One is the expression cot phi is equal to 1 by r dr by d theta, which is very important for exam point of view. Second, I have told you what is the expression for pedal equation and what is its derivation. So in my next video, I will be doing the questions. Okay. So as I told you, please go through the basic concept of log and the trigonometry. Even if you just understand these three properties of log and these half angle formulas and concept of allied angle, which you can see on the channel, then we can do the question very smoothly. I hope you like the explanation and you are very clear about the whole explanation. So subscribe the channel, share the channel and like the channel so that the moment I'll upload a new video, you will get a notification. Along with this, for first year students especially, I have uploaded all the videos of rank, then consistency, system of equation, eigenvalue and eigenvector, diagonalization, modal matrix. So all are under the linear algebra playlist. If you have any other doubt, any topic which you are finding very difficult or you are not understanding it, text me on a YouTube so that I can prepare a very simple video for you and upload it. So approach me whenever you have any doubt. Thank you.